Okay, guys, we will focus on non-rectangular region. Okay, we will focus on non-rectangular region. All right, so basically we will have this integration. Okay, so we have double integration. Let's say we have type 1. We have function of fxy. Okay, dy first and then goes to dx. All right, so for non-rectangular region, okay, what happened here, guys? The limit, let's say dy, okay, the limit here are involving functions, okay, involving functions where we have y equals to g1x until y equals to g2x. Okay, so means all the limits are functions for the inner limit. Okay, and then the outer limit should be constant. So constant we have from point A until point B. Okay, in other words, we can say that the inner limit here, okay, should be lines or curves because it's a function, okay, and the outer limits here are the points or coordinates, okay, lines and points. So for the first type 1, okay, for type 1 we have dy, okay, so the lines, since we have dy, thus the line should be moved from lower part to upper part, okay, lower line, lower to upper. All right, so that is the type 1 integration. Okay, for type 2 integration, again we have double integral fxy, right? But now we have dx dy. Okay, so the inner limit, again, inner limit here are also involve functions where we have x equals to, let's say, h1y, and then until x equals to second function, h2y, okay? And then, of course, the outer limit should be just a point. So we can say that y is from point C to D, okay? So again, here, for the inner limit, these are lines or curves, okay? And then the outer limits are just coordinates or points. All right. And now, guys, since we have dx first, okay, so the movement is from left to right, okay, left to right, left to right. Okay, I will explain further on this when we want to learn, when we learn about the reverse order of integration later, okay. So right now, let's take a look at exercise 4.3. I want you to understand this topic, guys, because this is very important, especially in your final exam. Okay, exercise 4.3. Let's take a look at this exercise. Okay, reverse order of integration. It's either you want to change from dy dx to dx dy or dx dy into dy dx. Okay, previously in subtopic 4.2, you can just switch the order of integration, just simply switch the limit. Okay, however, if you have non-rectangular region, you have to be careful. You cannot just switch the limit because the limits involve functions. Okay, I will explain later about this. Reverse the order of integration. This also will come out in your quiz form. All right, so let's go to the exercise first, exercise 4.3. Let us do question number 1, the simplest question first, so that you can, you will understand the concept of non-rectangular region. Okay, so basically, guys, when you have this type of integration, right? When the question asks you to sketch region R, okay, to sketch region R, means you have to refer to the limits. Okay, refer to the limits, not the function inside here. No, just refer to the limits. Okay, so we have this limit. All right, so the yellow color, you have to refer to these functions. Okay, so now we have y, limit of y equals to x squared over 2. Okay. Y equals to x squared over 2, and then y equals to x. Okay, so we have two functions here. And then the limit of x is from 0 until 2. So let us sketch the region, guys. So now we have this region, x and y. Okay,
Quadratic.
x squared over 2. Yes, very good. Quadratic. So we have upward quadratic parabola, right? We have something looks like this. Okay, this is y equals to x squared over 2. Okay, next we have y equals to x. So y
Straight line.
equals to this, just a straight line, yes. So we have this straight line. Okay, therefore the region should be this. All right, so that's the region. Okay, the yellow color. All right, so now, okay, x equals to 2. Where's the position of x equals to 2? Of course, we will have intersection, intersect point here, right? We have x equals to 2. Okay, so now let us solve this integration. From 0 until 2, x squared over 2 until x, we have x squared y dy dx. Okay, so we will have integration from 0 until 2. Okay, what's the constant now?
X.
Yes, x squared can be taken out. So we integrate y. So it becomes y squared over 2. Substitute x and x squared over 2 dx. Okay, so from here we will have integration 0 until 2 x squared. Let's say I take out the over 2. So we have x squared over 2. So substitute. Becomes x squared minus x to the power of 4, 2 squared, so over 4, like this, dx. All right, so let us expand this one. 0 until 2, so x to the power of 4 over 2, and then minus x to the power of 6 over 8, okay, dx. So now we can integrate this, x to the power of 5 over 5 times 2 is 10. And then minus x to the power of 7 over 56, isn't it? 7 times 8. So we have 0 until 2. So substitute the value. We will have 2 to the power of 5 over 10 minus 2 to the power of 7 over 56. What should you get? This one, 32 over 10, isn't it? 2 to the power of 7 should be 128. Betul ke? 56. Take out your calculator, guys. So what should you
32
get?
over 35.
All right, so we will have 32 over 35. That's it. That's the answer. Okay, now next, what happened, guys? We look at question number 2. Okay, question number 2. Okay, so now we have dx dy. Okay, previously we have dy dx. Okay, dy dx, dy first. So as I mentioned earlier, dy means from bottom to top. Okay, lower limit, upper limit. Okay, and then you have to note that all of these are lines. Okay, lines. Right, so lower line, this is the lower line. Okay, and this is the upper line. Okay, from bottom to top. Right, now for the second question, we have dx. dx first. So since dx dy, so we move from left to right. Okay, left to right. These concepts are very important, especially if you want to reverse the order of integration. Okay, so now x from y until square root of y. So we have two equations. Here x equals to y and another one x equals to square root of y. Okay, so next limit of y is from 0 until 1. So let us sketch the region R. X and y. Okay, x equals to y, of course we just have this straight line. Okay, x equals to y. Now how about this? X equals to square root y.
Dia melengkung ke positif, ke kosong, ke kosong.
Ke kosong macam mana tu?
Dia melengkung.
Okay, it's like this, okay? We can square both sides, right? X squared equals to y, isn't it? Can?
Yeah.
So x, y equals to x squared. Of course, we just have upward, upward quadratic, upward parabola. It's like this. Okay. But now we just consider x positive. Okay, because of square root sign, x must be greater than 0. So we can erase this part. So we can erase this, right? And then we have y from 0. Okay, ni point, ni titik. Ni point from 0 until 1. So of course we have point 1 here. Okay, so from left to right. This is the left line. Okay, from left to right, from left to right. So the left line is this one, the green color. Just this. Okay, the green color here. And then the right line should be the yellow color here. Okay, so that's what I mean by from left to right, the line itself. And then this is the region now, of course. Okay, this is our region R. All right. So let us proceed with this integration from 0 until 1. From y until square root of y, square root of x, y, dx, dy. Okay, so this integral can be rewritten as this. Square root of x multiplied by square root of y, dx, dy. So which one is the constant now?
Y.
Y. Okay, so we can take out square root of y because y is just a constant. So we are now integrating x to the power of half. Okay, x to the power of half. So integrate x to the power of half, we will have x to the
X to the
power of
power 3 over 2 over 2 over 3 over 2.
Yes, over 3 over 2 like this. Okay, and then we substitute y and square root of y dy. Okay, so now I would like to take this up here because it's just a constant. So dia akan jadi 0 until 1, 2 over 3, isn't it? Naik ke atas kan? So square root of y and then substitute x to the power of 3 over 2 here with square root of y and y. So we can have 0 until 1. Okay, y to the power of half to the power of 3 over 2 minus y to the power of 3 over 2, like this. Okay, and then next we have to expand this, multiply here and multiply here. So we will have okay. So we have y to the power of half. Okay, sekejap saya tukar macam ni lah dulu. Y to the power of 3 over 4 minus y to the power of 3 over 2. Okay, now baru kita dah masuk. 0 until 1, 2 over 3. Y to the power of 3 over 4. So 4, 2 plus 3. So 5 over 4 minus y to the power of dah masuk 1 over 2. Okay, so y squared lah. dy. Alright. So now we can integrate this. So 2 over 3 can be taken out. Okay, 5 over 4 plus 1, we will get what? Integrate 5/4 tambah 1. We will get 9 over 4, isn't it?
9 over 4.
Yes, so 9 over 4. So it becomes over 9 over 4. So 4 over 9 lah. Minus y cubed over 3. Okay, so substitute 0 and 1. So we have 2 over 3. Of course, substitute y equals to 1. Then we get 4 over 9 minus 1 over 3. And then minus 0, 0 lah. So altogether we will have 4 minus 3. So 1 over 9, isn't it? So 2 over 3 times 1 over 9. We will have 2 over 27. Okay. So that's the answer. All right, now let's take a look at question number 3. Okay, this question. Always bear in mind, if we want to sketch the region R, okay, region R is from the limit. This is region R. Just refer to the limit. Don't look at the function cos, because sometimes students always do mistakes. Just they sketch the graph of cos. This is not the graph, okay? The graph is 100% from the limit. All right, you have to bear in mind region R must be taken from the limit. Okay, guys, so now we have x. X equals to 0. Okay, this x equals to 0 and x also equals to y. So we will have an x equals to y. Okay. And you have to bear in mind x equals to 0 also means y exists. Okay. X equals to 0 means y exists. You can ingat macam tu Kalau y equals to 0,
X exists.
yes, x exists. Okay, good. And then in this case, we have limit of y from 0 until pi. Okay, so y from 0 until pi. Okay, so let us sketch the region. X and y. Okay, so x equals to 0. X equals to 0, of course y exists. So let's say we have this line. And then we have x equals to y. So x equals to y, just a straight line here. And then y equals to 0. This is a point. Y equals to 0. And then y equals to pi. Let's say pi here. Okay. So now the region should be this. Okay, this is your region R. Right, region R. Okay, x equals to 0 until x equals to y. So in this case, guys, we know here, this is dx dy. So as I mentioned earlier, dx dy, if x comes first, it means from left to right. Okay, left to right. So left line, left to right, like this. Okay, so left line should be this, the green color, ni. Okay, this green color, and then the right line, I use yellow color. This is the right line. Okay, from left to right.
Kata,
Yes, saya.
tengok dari zero kan?
Tengok dari zero. Tak, bukan. Ini yang saya kata tadi. Kalau dx dulu, you tengok line tu. Left line dengan right line. Okay. Left line yang hijau ni. Saya guna highlighter hijau ni. And then yang yellow ni right line lah. Ni x equals to y. And then this one, yang hijau ni adalah x equals to 0. Get my point? That's why you have to understand concept from left to right, from bottom to top. Okay? And then you have to bear in mind, yang belah dalam ni dia mesti lines. Lines. Okay, yang ni dia mesti garisan. Yang ni, yang outer limit should be points. Tak apa, nanti kita tengok soalan yang betul-betul yang baru you faham kenapa saya tekankan sangat benda ni. Okay, question number 5 nanti saya akan explain detail lagi benda ni. Alright, so let us proceed with the integration. We have from 0 until pi, and then we have from 0 until y, y cos x dx dy. Okay. So now, what is the constant now?
Y.
Y. Okay, so y can be taken out. We just integrate cos x with respect to x. Integrate cos dapat apa? What should you get?
Positive sign.
Positive sign, yes. So sign. Yes, very good. Sin x. Substitute x equals to y and x equals to 0 dy. Okay, so we will have 0 until pi. Y substitute sin y minus sin 0 dy. Of course, sin 0 is equivalent to 0. Okay, so we will have, oops, sorry. So we will have 0 until pi y sin y. Okay, how do we integrate, dy. How do we integrate this?
Substitute.
Substitute, I don't think so. But nice try, nice response. Thank you for responding me. We can use tabular method, guys. Still remember in chapter 2? Tabular method. All right, tabular method. Why? Because we have two types of function, y and sin y, multiplication. Okay, so of course when you use tabular method, we should have differentiation column and integration column. Okay, differentiate and integrate. Which one to be differentiated? We need to use log pad, isn't it? So which one, y or sin y, to be differentiated?
Y.
First.
Y.
Mana sin? Yang satu nak differentiate ni. Y ni poly kan?
Y.
Y trigo. Okay, so differentiate y. Okay, because polynomial comes first before trigo. So differentiate y lah. And then integrate, barulah sin y. Okay, so we have to differentiate y until we get 0. So differentiate y, we get 1. Differentiate 1, we get 0. Okay, differentiate. Okay, integrate sin y.
Negative cos y.
Yes, negative cos y. Integrate negative cos y.
Negative sin y.
Yes, negative sin y. Okay, good, well done. So don't forget, you have to put plus, minus, plus alternately, and then after that, you need to cross like this. Okay, you darab macam ni. Therefore, okay, 0 until pi, oh sorry, no need, no more, because we are now integrate this. So open the sharp bracket, square bracket, we will have negative y cos y minus minus become plus lah. Ni. Okay, so plus sine y. Substitute 0 and pi. So we will have negative pi cos pi plus sine pi minus 0 plus sine 0 also 0 lah. Okay, so cos pi is negative 1, sine pi is 0, so negative 1 times pi is equals to pi. Okay, that's it, that's the answer. Okay, next question. Question number 5. Question number 5, let us do this. Okay, so first of all, we need to sketch the region R. Okay, sketch the region R. We have a triangle of vertices negative to 0. Okay, this. All right, x and y, negative to 0. So here, negative to 0. And then we have point to 0. So to 0, coordinate x2 lah. So y 0. And then we have 0, 2. Let's say here, 0, 2. So this is the triangle. Okay, this is the triangle. All right, now, okay, guys. Let us find the equation for this line. Okay, so for this line, we have negative x over 2 plus y over 2 equals to 1, isn't it? So this is equivalent to negative x plus y equals to 2. All right, and then next, the equation for this line, we can also use the intersect form. We have positive x over 2 plus y over 2 equals to 1. Therefore, x plus y equals to 2. Okay, so now this is the region. Okay, this is the region. Okay, in this question, it does not mention whether dy dx or ds dy because dA. Okay, dA can be either dy dx or dx dy. I will show you both. Okay, I will show you both solutions. Okay, let's say we have method number 1. Let's say method 1, we use, let's say dx dy. Okay, as I mentioned earlier, if we want to have dx dy, means the limit should be moved from what? Limit should be moved from x.
Left to right.
Yes, left to right.
Left to right.
Left to right. Okay. So what happened, guys? Okay, integration. The function is y. Okay, y dx dy. Okay, as I mentioned earlier, the inner limit should be lines. Okay, garisan, lines. And then the outer limit should be coordinates or points, titik. Okay, so the inner limit, okay, since we have lines, okay, from left to right, so we will have this line. Okay, we will have this line. This is the left line. All right, so the left line is what x equals to, equation kita ni, x equals to what? Apa ni?
Y minus 2.
Yes, x equals to y minus 2. Okay, so x equals to y minus 2. This is the left line. And then the right line, x equals to?
Negative y plus 2.
2 minus y kan? Sama lah. Okay, so 2 minus y. Okay, now the points of y from?
0 to 2.
Yes, 0 until 2. Okay. So this is how we solve by using dx dy from the left line until the right line. Macam tu, left to right. Okay, that is the first method. Second method, method 2. Let's say we use dy dx. Okay, so now let's say again I resketch the graph so that you can understand what I mean by move from left to right, bottom to top. Okay, so x, y. So dia macam ni tadi kan? We have -2, 2 and 2. So of course this is the region, the same region. Okay, and then we have this tadi apa? Negative x plus y. And then this one x plus y equals to 2. Okay, now we want to use dy over dx. Okay, dy over dx. So double integration y dy dx. Okay, as we know, dy dx means the movement is from bottom. Okay, dy means from bottom to top. Okay, so can you give me the lower limit of y? Y equals to? What's the lower line?
X equals to 0 and y equals to 0.
Y equals to 0, okay, betul. The upper line should be y equals to?
Modulus.
Modulus.
Sebab dia dua line.
Dia ada dua line kan? Okay, right. Now, okay guys, listen here carefully. If you want to use dy dx for this question, we know that we need to identify for dy dx, this is lower line dengan upper line. Upper line. Okay, so lower line tak ada masalah. We don't have any problem because y equals to 0. However, the upper line, we have two lines. So which one? So in order to solve this by using dy dx, you have to break this into two parts. Okay, you have to break this into two parts. So you have part A and part B. Jadi leceh sikit, dia tedious sikit. Okay, so you have part A and then you also need to have part B. Sebab kita nak pilih line atas yang mana? Kan konsep dia lower line dan upper line kan? So kita kena start satu-satu. We have to separate. Okay? So the lower line for part A is y equals to 0 and then the upper line should be this line. Okay? So we have this from bottom to top. Okay? From bottom to top. So for part A, the upper limit of y should be?
X plus 2.
Yes, okay, so y equals to x plus 2. Okay, now the limit of x. Ingat, kat luar ni adalah titik, points. So the coordinate of x should be from?
0 until -2.
Negative 2 is smaller, okay, negative 2, yes, negative 2 smaller, so we should have -2 until 0. Okay, so settle on part A. How about part B? We have y dy dx. Okay, so part B, we know that we start from bottom to top because we consider dy dx. So the bottom line, of course, I believe all of you already understand this, y equals to 0. So what's the upper line?
2 minus x, y equals to 2 minus x.
Upper line, garisan atas dia. So we have, y equals to 2 minus x. Okay, so 2 minus x. And then how about the limit of x?
0 until 2.
0 until 2.
Yes, 0 until 2. Okay, so if you use dy dx, you kena tambah a plus b. Dapatlah jawapan. But if you use dx dy, the first method, just only one integral involved here. Okay, you jawab macam ni je. Yang ni. Hanya satu saja kalau you pilih dx dy. But if you choose dy dx, you kena cari dua benda. Jadi macam ni pula. So understand what I mean?
Faham.
Okay. So
Depends on the situation.
but the answer will be same. Don't worry. Okay. The answer will be the same. Cumanya dalam soalan ni, if you use the first method, it's much easier because we just only have one integration. Kalau you guna second method, dy dx, you kena pecah dua, jadi part A dengan part B. Okay? So I think you can proceed with the solution. It's just a very simple integration. So right now, let us do question number 6. Nah, ni saya tunjuk sampai habis lah. Question number 6 ni dia complicated sikit. Question number 6. Okay, right. Let us sketch the region. We have y equals to 4 over x. Okay, so the region, let's sketch the graph. Okay, y equals to x, y, 4 over x. So should be like this.
Macam tangent.
Dia macam ni kan? Betul tak?
Asymptote 0.
Macam tu. Okay. And then we also have y equals to x. Y equals to x. So y equals to x, just a straight line. Yes, just a straight line like this. Dia touch 0, 0 ni kan? Okay, next we have x equals to 4. Alright, so now guys, before you plot the point x equals to 4, we need to know the position of x equals to 4. Dekat mana position dia? Okay, but first we need to identify. Okay, we need to identify the coordinate of this point. And the coordinate of this point. Okay, so how do we find this? This is the intersection point, isn't it? Intersection between, okay, y1 equals to y2. All right. So y1 is equals to 4 over x, bukan substitute, equate this with second y equals to x. Okay, so we have 4 equals to x squared. Therefore, x squared equals to 4, so x equals to plus minus 2. So we know that here is 2, right here should be negative 2. Okay, so barulah kita tahu position x equals to 4 kat mana, betul tak? Kita tak boleh main simply plot je x equals to 4 tu. Faham tak apa maksud saya? Sebab kita nak tahu position dekat mana. Dekat mana beradanya x equals to 4. So from here we know that of course x equals to 4, belakang sikit lah. X equals to 4. So this is the line of x equals to 4. Okay, x equals to 4. Okay, now, where is the region? Kat mana kita kena shape region ni?
Tengah-tengah tu.
Tengah-tengah. I don't think so. Kalau tengah-tengah mana? Ya ni, bawah ni? No.
Atas
Atas
tengah-tengah.
dia.
It must be bounded by these 3 equations, isn't it? Dia kena ada ketiga-tiga lines tu. Okay, dia kena ada ketiga-tiga lines tu. So, yang curve ni kena ada. Yang ni pun kena ada, x equals to 4 and also this one. Okay, so this is the line. This is the region. Region R. Region R. Okay, now, can you tell me which one easier, dy dx or ds dy for this question?
Dx,
Okay, remember dalam mana dah? Remember kalau double integration dan rectangular region dalam ni kenalah lines. So you imagine dy dx ke ds dy lebih mudah?
dy dx.
dy dx.
You very good. dy dx. Kenapa dy dx? Sebab garisan, yes, lines, lower lines until upper lines sekaligus je. Okay, from bottom to top. Alright, so the bottom line is y equals to 4 over x And then the upper line should be y equals to x. Okay, so yang x hanyalah titik lah 2 sampai 4. Betul tak? Kalau you guna dx dy, you kena pecah ni. You kena pecahkan bagi jadi 2 bahagian kalau dx dy. So in this case, it's much easier if we use dy dx. Okay, so dy dx. Apa function tengah dia? xy. xy dy dx. So the lower line here, warna hijau. Okay, the lower line here is y equals to 4 over x. Okay, so y equals to 4 over x. And then the upper line here should be y equals to x. So y equals to x. And then now the limit of x just point from 2 until 4. Okay, from 2 until 4. Okay, good. So now let us proceed with the integration. 2 until 4. Okay, so right now we integrate with respect to y. Of course, s just a constant. Then we will have y squared over 2. Substitute x and 4 over x dx. Okay, so we will have 2 until 4. Okay, x over 2 can be taken out. X over 2, saya buat keluar siap-siap lah. And then we will have x squared minus 4 over x squared. So 16 over x squared like this, dx. All right. So let us take out 1 over 2. And then we will have 2 until 4. You darab masuk jadi x cube. Minus x darab ni jadi 16.
16 over x.
Over x, yes. Okay, good. So now, let us integrate this 1 over 2. X to the power of 4 over 4 minus, integrate, ni dapat apa?
Plus 16 x.
Yes, 16 ln x. Right, 16 ln x. Understand, guys? So we have here 2 and 4. Okay, so we will have 1 over 2. Substitute 4 kuasa 4 bagi 4.
4.
Mana 4?
16 kan bagi 4.
4 kuasa 4, bukan 4 darab 4.
Oh, lupa. Ingatkan 2 kuasa 4 tadi.
4 kuasa 4. 256 divide by 4. So 4 cube lah kan. So 4 cube is 64, isn't it? Minus 16 ln 4 minus 2 to the power of 4 is 16. 16 divided by 4 is 4 lah. Minus 16 ln 2. Macam tu. So we will have 1 over 2, 64 tolak 4 jadi 60. Kan? 60 tolak okay, let's say 16. Ni jadi tambah kan? This one. Minus become plus. So ln 2 minus ln 4 lah. Like this. Okay, so we will have multiply by half.
Dan 1 over 2.
Yes. So, saya darab ni dulu. Saya darab yang ni. 1/2 ni jadi 30 tambah 8, isn't it? Ln 2 divided by 4. Okay, good. So we will have 30 plus 8 ln 1 over 2. Or 30 plus 8 ln 2 to the power of negative 1, isn't it? So this is also equals to negative 8 ln 2. Like this. Tapi kalau you jawab sampai sini pun dah betul, guys. Doesn't matter lah. You just simplify je. Alright. So that's question number 6. What else? Okay, semicircle would be simple. Okay, let us do question number 8. Look at question number 8. Oops. Okay, we have a circle and then we have this line. Okay, so let us plot the graph. What's the radius of this circle?
3.
3. Okay, very good. So we have a circle with radius 3. Okay, out here 3, 3, negative 3, negative 3. Okay, next we have y equals to x plus 3. Line y,
Straight line.
straight line. So y over 3 minus x over 3 equals to 1, isn't it? So y positif 3, betul dah. Ni saya pakai marker pen biru lah. Okay, so y equals to 3, x equals to negative 3. Kat sini kan? Sini. So we have this line. Okay. And then the question also mentioned in the second quadrant. Yes, in the second quadrant lah. Okay, so this is the region R. Okay, so in this case, it's already given. You have to find dy dx, right? So dy dx, of course, from bottom to top. Okay, so we will have integration y dy dx. Okay, what is the lower limit of y? The lower line.
X plus 3.
Yes, x plus 3. Okay, good. The upper line should be?
Negative x squared plus 9. Set negative x squared plus 9.
Dia balik kan? So, x squared plus y squared equals to 9. Therefore, y equals to square root of 9 minus x squared. Okay, so we will have square root of 9 minus x squared. And then x from?
0 until 3.
You go 0 until 3. Second
Negative.
quadrant.
Negative 3 until 0.
Yes, negative 3 until 0. Negative 3 until 0. That's it. Okay, that's question number 8. Number 8. So you can proceed lah integration dia. Saya nak go to question number 9, 10, quite simple. Let's take a look at question number 11. Kita tengok volume. Okay. So basically guys, volume equals to double integration towards region R. We have fxy dA. Okay, so of course fxy is actually your z, function z. Okay, this is your z. And dA can be either dy dx or dx dy lah. It's up to you. So in this case, okay guys, what happened here? We have x plus y plus 2z equals to 6. So if we sketch the graph in 3D, let us use the intersect form. We have y over 6, we have z over 3, isn't it? Equals to 1. So we will have x, y, and z. So we have 6, y also 6. Oh, sorry. And then z equals to 3. So we will have this plane. Okay. And you have to bear in mind, guys, ni, region R ni. Okay. Region R must be on XY plane. Okay, maksudnya paksi XY, dia 2D. So on XY plane, we will have this region. Okay, this region. So this is your region R. Alright, so if I resketch region R, region R like this. X and y, so x equals to 6 of course, y equals to 6, so this line.
Memang XY plane je, doktor.
Sebab di region R. Okay. Sebenarnya plane ni, okay, saya advance sikit ni saya ajar juga ni. Region yang plane ni, ini adalah region G. Region G means 3D, 3 dimension. Region R is 2D. Good question. Okay, good question. Never mind. Kita akan belajar lebih banyak lagi dalam region G ni in subtopic 4.5, triple integrals. Triple integrals nanti kita banyak sketch region G lah. So, ni saya sketch dulu so that you faham konsep kita yang sebenar. Okay. So daripada 3D tu kita come out dengan region R, kita tengok daripada tapak dia lah. So we have region R on X and Y axis. Okay, so basically the equation for region R, garisan ni, this line, of course we have X over 6 plus Y over 6 equals to 1, isn't it? So X tambah Y equals to 6 lah. Okay, so now we need to calculate the volume. Okay, before that we need to find the Z. Okay, X plus Y plus 2Z equals to 6. Therefore, 2Z equals to 6 minus X minus Y. Therefore, Z equals to, divide by 2, we have 3 minus X over 2 minus Y over 2. Okay, so kita punya volume akan jadi double integration. Alright, and then Z. So, this is your Z. Okay, kat tengah-tengah tu tadi Z kan, formula dia kan? Ni. So kat tengah-tengah ni kita ambil yang ni lah. 3 minus X over 2 minus Y over 2. Okay, now you pilih. You nak DY dx ke dx dy berdasarkan region ni? Berdasarkan region ni.
Mana-mana.
Mana-mana. Yelah, you pilih lah. You nak yang mana? Pilih. Saya ikut soal yang awak nak.
dx dy.
dx dy. Okay, so when you say dx dy means you have to move from
Left to right.
left to right. Okay, well done. Left to right. Okay, dx dy, left to right. So let us put dx dy, left to right. So the left line should be left line.
X equal to 0.
X equals to 0. And the right line should be x equals to
6. 6 minus Y. 6 minus Y.
6 minus Y. Dia garisan you kena ingat ni. Letak dalam kepala. Ni adalah garisan, lines. Kat luar ni baru titik, points. So the limit of Y should be from
0 until 6.
yes, 0 until 6. Okay. Alright, so I think you can proceed with the integration lah. Saya nak ajar sekarang ni reverse order of integration setelah tak sempat. Okay, it's okay guys. If you have any problem later, you can WhatsApp me personally. Okay, kalau you tak dapat jawapan tu. Right now, I want to teach you about reverse the order of integration. Ini masuk test dan masuk final juga if I'm not mistaken. Reverse order of integration. Okay. So now, let's take a look at question number 16. Okay, kita ambil yang ni. Yang ni garis dulu je 15, just straight line. Kita ambil question number 16. Reverse the order of integration. Alright. Before you can reverse the order, first of all, you have to sketch the region. Okay, you gonna sketch region. Alright. Now, we have the limit of Y. Y is from 0. Okay, so Y equals to 0. And another line is Y equals to square root of X. Okay, Y equals to square root of X. And then the point, okay, titik kita ada X from 0 until 4. Okay, 0 until 4. So let us sketch the region first. Okay guys, so now we have Y equals to square root of X. So this is equivalent to X equals to Y squared, isn't it? Kalau kita square both sides.
Yeah.
So the parabola should be facing to which
Kanan.
Yes,
Right.
on the right. Yes. So on the right. So it should be like this. On the right. Okay, macam ni kan. However, y equals to square root of x, so we know that y must be greater or equals to 0 lah. So we can erase this part. Okay, we don't have this part lah. Ni tak ada. Okay, and then x equals to 0. X equals to 0. Sorry. X equals to 0 here. 0. And then x equals to 4. So 4. Like this. Okay, can you give me the coordinate here? How do we find the coordinate here? So how do we find when x equals to 4, isn't it? We know that y equals to square root of x. So y equals to square root of 4 equals to 2. Okay, so we will have the value here should be 2. Okay, now guys, we want to reverse the order of integration. So instead of dy dx, we need to convert or reverse the order into dx dy. Okay, into dx dy. So bila dx dy, the movement is from where to where?
Left to right.
Yes, from left to right. Okay, left to right. So from left to right, okay, this is the movement from left to right. Okay, we have this region. Okay, now double integration of this function dx dy. So x from left. Okay, what's the equation of the left line? Here.
Set X.
Here ke square root x?
Y
Mana?
square, Y square, Y square.
Square root x. Ni kan y equals to square root x kan? So x equals to y squared lah. Okay, y squared. Until x equals to, what's the left line? Ni. Yes, 4. Okay, that's the left line. So x equals to 4. Okay, next y. Y from
0 to 2.
0 until 2. Yes, from 0 until 2. Just point. Coordinate je. 0 until 2. Understand, guys? Reverse order?
Yeah.
Okay, let's do another question. Question number 17. Copy. Okay, question number 17. Pukul 5 lah. Saya baru nak stop pukul 5:30 tak sempat ni. Saya kena habiskan juga. Okay. Alright, question number 70 is quite interesting. We have dx dy, so x equals to ln y and x equals to 0. Okay, x equals to 0 means what, guys? Saya ada cakap tadi.
Y exists.
Y exists.
Okay, good. X equals to 0 means y exists. Alright, and then your y, limit of y is from exponent -2 until 1. Guys, can you give me the values of exponent -2 in decimal? Equals to, in decimal.
0.135.
0.135. 0.135. Okay, so let us sketch the graph. X and Y. You kena sketch graph ni. Graph ln ni. X equals to ln Y. So ln 1 equals to 0. So dia akan intersect dekat 1 lah. So it should be, looks like this. Sorry. Should be looks like this. Macam tu lah lebih kurang. Okay, and then here ln Y, ln 1 equals to 0. So 1 here. Okay, and then as we know, exponent -2 is less than 1, 0.135. So that's why we will have the coordinate should be here lah. Okay, exponent -2. kat mana dia punya region ni? Kat mana nak shape region dia guys? Kita ada y-axis kan, x equals to 0, isn't it? So we have this line. Kita ada garisan ni, y equals to 0, and then the left line is x equals to square root y. Okay, and limit of y from exponent negative 2 until 1. So we have this region. Okay, so we have this region. All right, now we need to change from dx dy into dy dx. Okay, into dy dx. So dy dx, we need to change from dx dy to dy dx. So dy dx means from bottom to top. Okay, so from bottom line to the top line. Okay, so now we have double integration fxy dy dx. Okay, can you give me the lower limit, the lower line? Y equals
e to the power of negative 2.
yes, exponent to the power of negative 2, this line. The upper line should be y equals to
2 ln y.
X equals to ln y. So y equals to
E to the power of x.
yes, exponent x. So exponent x. Now guys, what is the limit of x? Macam nak tahu limit of x ni? Satu lagi tertinggal ni. Ni kita kena tahu titik ni. Okay, so how do we find this coordinate? Macam nak tahu coordinate kat situ? We have to equate. Yes, equate. Alright, so we have to equate when y equals to exponent negative 2. We know that x equals to ln y, isn't it? So x equals to ln exponent negative 2. We will have x equals to negative 2. Yes, so here should be negative 2. Macam tu. So what's the limit of x?
0, negative 2 until 0.
Yes, x equals to negative 2 until 0. So kat sini 0. Understand? Understand guys? Okay. So next, double integrals in polar coordinates. This also will come up in your quiz and final exam. Okay, subtopic 4.4. Double integrals in polar coordinates. So basically, double integrals in polar coordinates, we will have double integration towards region R. Okay, before this we have fxy, but in this case we will have fr and theta. Okay, our function must be in terms of radius and angle. Okay, r and theta. And then we will have dA. Okay, previously dA is either dy dx or dx dy. But in polar coordinates, dA means tiga beradik. Yes, r dr d theta. Ada tiga terms. Okay, r dr d theta. Tiga beradik tu, kena ingat tu. Okay, so now let's do exercise 4.4. Okay, look at this question. 4.4. Question number 1 is quite easy, so let us proceed to question number 2. Okay, first of all, you have R, Okay, r equals to 1 and r equals to 2. Ni, limit ni. Okay, so what are they? R equals to 1 and R equals to 2 ni apa?
Line.
You ke line.
Tak. Apa tu circle?
Radius.
Betul.
Radius.
Radius, tapi dia adalah membentuk circles. Okay, good, very good. So, they are circles. Okay, with radius 1 and radius 2. So, bulatan. You all ada 2 bulatan dah ni. Okay, so jom kita sketch region R kita sekarang ni dalam bentuk R dengan theta. We have X and Y. First circle is radius 1. Second circle is radius 2. Okay, here is 1 and then here is 2. Okay, and then you have angle. Okay, guys, angle theta from pi over 2 until pi. Okay, so
Second
theta
quadrant.
from pi over 2 until pi. Right, second quadrant. Yes, correct. So we will have, okay, here theta equals to pi over 2 and then theta equals to pi. So we have this region R. Suku donat je. Okay, so that's your region R lah. Alright. So let us proceed with the integration. So pi over 2 until pi. Integrate R with respect to R. Of course, we will get R squared over 2. Substitute 1 and 2 d theta. So we will have pi over 2 until pi. 2 squared divided by 2. So 4 over 2 minus 1 over 2 d theta. We will have 3 over 2. Integration from pi over 2 until pi d theta. So integrate 1 with respect to theta, we will get theta, isn't it? So pi over 2. Okay, so we will have 3 over 2 pi minus pi over 2. Then 3 over 2 times pi over
1
2.
over 2 pi.
Okay, so we will have 3 pi over 4. Betul ke jawapan 3 pi over 4 ni? 3 pi over 4
over 2.
kan?
Okay.
3 pi over 4 kan? Ni kan darab 2 kali 2, 4. Okay, so next. Let us do question number 3. Okay, question number 3. Okay, we have R equals to 4 sine theta, right? R equals to 4 sine theta. So graph kita kat mana ni? 4 sine
Y.
theta ni bentuk apa? Paksi Y kan?
Bulatan.
Yes, a circle on y-axis. So we have this circle. Chapter 1. Ini yang saya kata tadi, yang saya kata hari tu the lesson in chapter 1 will be used again in chapter 4 ni. So here is 4, right? And then we have theta from 0 until pi over 3. So of course we know that here is theta equals to 0 and then pi over 3 is 60 degrees. So should be here, pi over 3. So should be this line. Okay, therefore the region R should be this. Alright, so let us proceed with the integration. Equals to 0 until pi over 3. Okay guys, so we have, okay, antara R dengan cos, which one yang constant? Cos theta, yes, so cos theta can be taken out. So R integrate becomes R squared over 2, substitute 0 and 4 sine theta d theta. Okay, so we will have
16 sine squared theta.
yes, so we will have 16 divided by 2, we have 8, right? So cos theta darab dengan 8 sine squared theta lah, d theta. Okay, now we will have this pi over 3, 8 cos theta sine squared theta d theta. Any idea how do we solve this integration?
Keluarkan tak.
Kena buat macam mana ni?
Keluarkan
How do-
sin, dapatkan sin tu keluarkan.
You tak boleh keluarkan. Macam nak keluarkan? Dia kan theta, dulu theta ni. Variable dulu ni.
Sin theta darat sin theta, lepas tu, okey, faham.
Any idea guys? My brilliant students. How do we integrate this?
Trigonometry.
Tukar sin 2 theta tu jadi 2 sin theta cos theta.
No. Okay, nice try. It's okay. Never mind. Don't worry. I'm happy with your answer, but that's not the way. So how do we solve this? Is by using substitution. Okay, we let u equals to sine theta. Right? So differentiate u, we will get cos theta d theta. Okay, so in this case, d theta equals to du over cos theta. Okay, I would like to change the limit. Okay, I would like to change the limit. So right now, when theta equals to pi over 3, we will have u equals to sine pi over 3. Sine pi over 3 is square root 3 over 2. Sine 60 degree, kan? And then when theta equals to 0, so u equals to sine 0. So we have 0. Okay, so let us proceed with this integration. Okay, it becomes integration. Limit of pi over 3 change into square root 3 over 2. And then limit of 0, 0. Okay. And then we have 8 cos theta, so 8 cos theta. And then now sine squared is equals to u squared. So u squared. And then d theta is equivalent to du over cos theta. Okay, d theta is equals to du over cos theta. So we have du over cos theta. So we can cancel this happily. Okay. So our integration becomes 0 square root 3 over 2, 8 u squared du.
Over 3.
Yes, so we will have 8 multiplied by u cubed over 3, substitute square root 3 over 2, and then 0. So let's take out 1 over 3, so we have 8 over 3. So square root 3 over 2 cubed minus 0 cube, of course 0 lah. So we will have 8 over 3 multiplied by square root 3 cube is 3 square root 3 over 2 cube is 8.
Over 8.
Yes. So we can cancel this and then also this one. And then we will have square root 3. Okay, so that's the answer. Right, next, let's take a look at, kita ambil soalan mencabar sikit lah. Question number 8. Okay, yang question number 6 just simple je, cardiac biasa. Number 7 pun just roses, direct juga lah. So kita ambil yang combination. Question number 8 Use a double integral in polar coordinates to find the area of the region inside the circle and above the line. Okay, ni tricky sikit soalan ni. Alright, let us sketch the graph first. So we have x, we have y. What's the radius of this circle?
2.
2. Okay, because we have x squared plus y squared equals to 4. So we will have r equals to 2. Okay, let's say this is the circle. This is 2. X squared plus y squared equals to 4. So r squared equals to 4. Therefore, r equals to 2. Okay, next we have the line y equals to 1. Line y equals to 1. Let's say we have 1 here. So the line should be this. Okay, line y equals to 1. Therefore, this is our region. Okay, this is y equals to 1. Okay guys, now we need to find the bounded angle, the intersecting angle. Find
With the X.
the intersecting angle. So how do we find the intersecting angle? Subtopic 4.1 hari tu, last week kita belajar. We have to equate R1 and R2, isn't it? Ingat tak? Okay, so R1, we have R equals to 2, isn't it? R equals to 2. R2, okay, R2 is taken from Y equals to 1. Since Y equals to 1, thus Y is equivalent to what in polar coordinates? Polar equations. Y equals to?
R cos, R sin theta.
Yes, R sine theta equals to 1. Therefore, R equals to 1 over sine theta. Okay, so second R is 1 over sine theta. Alright, so now sine theta is equals to 1 over 2. So theta is arc sine of 1 over 2. We have what? Theta equals to 30 degrees, isn't it? Or pi over 6. Okay, so now we have the intersecting angle should be here. Okay, theta equals to pi over 6. How about this?
Negative pi over 6.
Mana negatif pi over 2 jauh sangat tu.
Negative pi over 6.
Negatif pi over 6 kat bawah ni.
Tak, salah. Oh, lupa. Maaf.
Tak apalah, nice lah. Bila you jawab macam ni, at least a student, at least you knows the position kan. So ni bukan kan. So berapa?
2 over 3 pi. 2 over 3 pi.
You cool. How do we find
Pi
this?
minus pi over 6.
Ni saya padang tak? Saya nak tahu ni. Okay, let's say this is first theta, this is the second theta. Alright guys. So the first angle here is 30 degrees, isn't it? Pi over 6. So how about this from here to here?
150.
Yes, 150, good. So guys, theta 1 equals to pi over 6. So theta 2 is equals to pi minus pi over 6, isn't it?
Yes.
150, so 5 pi over 6, yes. So here should be 5 pi over 6. Okay, very good guys. Saya suka kita discuss macam ni. So that you can understand the position. Okay, so you have to be careful. So that will be 5 pi over 6. So now, jom kita start calculation. Dia nak area kan soalan ni? Yes, area. Area of the region. Okay, so area equals to integration from pi over 6 until 5 pi over 6. Okay. R equals to what? Until R equals to what? R daripada mana ke mana guys? Berdasarkan region ni. Limit of R.
Ya.
R theta. Limit of R. R adalah daripada ni garisan Y equals to 1 kan? Garisan ni guys. Y equals to 1 kan? Garisan ni kan? Sampailah ke garisan ni, isn't it? Okay, so Y equals to 1. Kita dah tahu tadi dah. Alright. Y equals to 1. 1 over R sin theta equals to 1. So R equals to 1 over sin theta, which means that R equals to 1 over sin is equivalent to what? Cosecant theta, isn't it? Sudah. Soalan kalau keluar final macam mana ni nak jawab ni? So cosecant theta. How about the upper limit of R?
X squared plus 4.
Dari lengkung ni kan. So lengkung ni radius dia berapa?
Tu.
2.
R equals to 2.
Yes, R equals to 2. Okay, good, very good. So now let us proceed. Okay guys, saya tak suka sangat 5 pi over 6 ni. Let's say saya nak kecilkan dia. Sebab nanti dia leceh bila nak substitute. Or alternatively, if I consider half of this angle, I will consider until theta equals to pi over 2, isn't it? So we will have area, area equals to 2 multiplied by from pi over 6 until pi over 2. Yang tadi tu dia keseluruhan, tapi saya tak suka 5 pi over 6 ni, susah nak kira. So saya akan ambil pi over 2 lah, common angle kita. And then R equals to cosecant theta. And then R equals to 2. R d theta. Both will give you the same answer, don't worry. If you comfortable with 5 pi over 6, doesn't matter. You can use the first one. But for me, I would rather use the second one. Okay, so now, we have 2 pi over 6 until pi over 2. Integrate R squared over 2 lah jadinya. So this one jadi 2, this one jadi cosecant theta. D theta. Apa dia?
Cancel 2.
Okay, so now this can be cancelled, right? Ni boleh cancel dah ni. Okay, so we will have integration pi over 6 until pi over 2, 4. 4 minus cosecant squared theta d theta. Alright, so now integrate 4 becomes 4 theta. Sudah. Integrate ni jadi apa ni? Guys, you beli buku, you pernah belik tak sampai muka surat last sekali? Okay, you tak beli buku ni. Applied calculus. Kalau you tengok page last sekali tu, sekejap saya scroll, kita ada appendices, kita ada list of formulas on the last page. Ni. Appendices ni, we have list of formulas. See? We have this, so we need to use this one. Integrate cosecant squared becomes cotangent, negative cotangent x. Okay, so we will use this. Right, we are going to use this. So, what happened? Plus or minus cot? Plus. Yes, becomes plus sebab dia negatif ni kan. Ni negatif ni. So, dia jadi plus lah. Okay, so plus cotangent theta. Substitute pi over 2, pi over 6. Okay, now cotangent ni sama dengan apa guys? You all nak guna calculator?
Cos over sin.
Ada cotangent kan? Yes, 1 over tangent. Okay, 1 over tangent. So we need to substitute the limits now. 4 times pi over 2 plus 1 over tangent pi over 2 minus 4 times pi over 6 plus cotangent pula 1 over tangent pi over 6. Okay. So right now we have 2 pi plus tangent pi over 2 is actually infinity. So 1 over infinity minus we have 2 pi over 3 plus 1 over tangent 30 degrees. So tangent 30 is equals to square root 3 over 3. 1 over square root 3 over 3. Like that. So this one guys, 1 over infinity sama dengan 0.
0.
Yes, so 0. So we will have 2 pi minus 2 pi over 3 minus 3 over square root 3 lah, terbalik. Sebab dia 1 over square root 3 kan. So we will have 2 pi 6 tolak 2, 4 pi over 3
4
isn't
over
it?
3.
4 pi over 3 minus jadinya square root 3. Okay, so that's the answer. 4 pi over 3 minus square root 3. Okay. Next question. Alah, kena scroll balik sekejap Scroll balik ke atas. Spherical. Lepas ni triple integral lebih mencabar lah guys. That's why saya nak you faham betul-betul konsep double integrals over non-rectangular region ni. Dengan this one, okay, 4.4. Ni dah. Ni. Sorry, triple integrals pula. Alright, this. So now let us do question number 9. Kita ada exponential sekarang ni. Copy. Okay. Now guys, question number 9, you have in rectangular coordinates, you have x and y, but now you need to change into polar coordinates. Okay, we know that we have a semicircle, y equals to square root 9 minus x squared. So it should be like this. So semicircle ni belah mana? Right, left, upper, upward or downward?
Left.
Left, are you sure? Ni y kan?
No.
Upper part kan? Upper part. Ni.
Apa?
Upper part of semicircle. So kita ada yang ni. What's the radius?
3.
Yes, okay, square root of 9 minus x squared. So we have x squared plus y squared equals to 9. Therefore, r equals to 3. So here 3. Okay, and then of course, right here should be negative 3 until 3. Okay guys, now, okay, this is your region R. What's the angle here?
5.
0, right?
0, 0.
Until theta equals to 5.
5.
Okay, so let us proceed. We have this integration, region R, exponent negative 2x squared plus y squared dA. Okay, so we have to convert this. Okay, first exponent negative 2 what? This is equals to what?
R squared.
Yes, R squared. Okay, good. How about this? dA is equivalent to what?
R dr d theta.
Yes, okay, kita ada R, dr, d, theta. Ada 3 beradik tu, you kena ingat. Okay, so that is your dA. Okay, now radius R from where to where? Okay, R from 0 guys. Cara kita baca adalah daripada pole ni 0 until 3, 0 until 3, 0 until 3, 0 until 3, 0 until 3. Macam tu. So R, of course, R is from 0 until R equals to 3. How about the angle? Of course lah, dah tahu dah tadi kan? 0 until pi. So now, how do we integrate this? Any idea?
Substitute.
Yes, we use substitution. So, kita nak substitute apa ni? Let u equals to what? Negative 2 r squared.
R squared.
So negative 2r squared, differentiate u, we will get negative 4r dr. Okay, so dr should be negative du over 4r. Macam tu. So now I would like to change the limit. So when r equals to 3, I have u equals to negative 2 times 3 squared. So we will have negative 18. And then when r equals to 0, we will have u equals to negative 2 times 0 squared. Yes, so becomes 0. So let us change the integration. Of course, the outer limit should be the same, 0 until pi. But the inner limit, we have to change r equals to 3 into negative 18. Okay, so negative 18 lah dekat atas. Dia ambil position 3 tu. And then r equals to 0, of course, when r equals to 0, u also 0. So we have 0 here. And then exponent negative 2r squared. This is equivalent to u. Okay, so exponent u darab dengan r, dr jadi negative du over 4r. So negative du over 4r. D theta ni copy balik sajalah. Okay, so now we can cancel this r and this r. Okay, so we can take out the coefficient. We will have negative 1 over 4. So 0 until pi, 0 until negative 18, exponent u du d theta. Okay, so integrate exponent u jadi mudah lah.
Exponent u.
Exponent u juga. So we will have exponent u, substitute u equals to negative 18, u equals to 0 d theta. So we will have negative 1 over 4, 0 until pi, exponent negative 18 minus exponent 0 d theta. Okay, so this one you dapat apa ni? Negative 1 over 4, 0 until pi. Exponent negative 18 minus minus 1. Okay, semua ni constant tau. Semua ni constant. So kita boleh bawa keluar pun. Okay. So dia akan jadi negative 1 over 4. Let's say saya jadikan dia positif. So terbaliklah 1 minus exponent negative 18. 0 until pi d theta. Okay. So we will have 1 over 4. Exponent negative 18 theta. Substitute pi and 0. So jadilah pi over 4, 1 minus exponent negative 18. That's it. That's the answer.
Wow.
Understand?
Faham.
Okay, so next. Saya ingat nak stop pukul 5.30 tapi tak sempat. Kita buat satu lagi soalan, guys. Okay, let's take a look at question number 13. Okay, question number 13. Copy. Okay, biasanya kalau soalan macam ni, dia suruh you convert to polar coordinates. So what you should do first of all is you have to find the equation. We know that y equals to square root of 3x minus x squared. So what you should do now is you have to square both sides. Okay, so we have x squared plus y squared equals to 3x. Okay, now we need to convert this into polar. So dia jadi apa ni?
R square equals to 3 cos. 3r cos
theta kan? X equals to r cos theta kan? So kita bahagikan r, we divide r, therefore r equals to 3 cos theta. Okay, so how does it looks like? Graph. What type of graph do we have here?
Bulatan ke kanan.
Yes, a circle on the right side. We have x, we have y. Okay, so we have this circle and the value here should be? What's the coordinate? 3. Okay, good. So now guys, if you notice here, y is from 0 until square root of. Okay, y from 0 until square root of 3x minus x squared. So y daripada 0. Y daripada 0, y equals to 0 means apa tadi saya ajar?
X-axis.
X-axis. Okay, so now x-axis is this. X-axis. And then y equals to square root of 3x minus x squared is this line. Okay, therefore this is the region. Saya sebelah atas sajalah. Okay. Alright, and then yes, of course lah, x daripada 0 until 3. Okay, so jom kita tukar jadi pola. Dia ada function tak ada. Okay, dy dx means nak tukar pola ni. Dy dx means r dr d theta. Tiga beradik kan. So letaklah r dr d theta. Okay. Now according to this region R, ni region R you all ni. So radius is from where to where?
Pi and 0 until pi over 2.
Itu theta lah, betul lah. Theta equals to 0 until pi over 2. How about the radius? Limit of radius?
3 over 2.
Ayuh.
Ada radius.
Bukan, dia macam gini. Kan saya cakap tadi, kalau pola, cara tengok dia adalah daripada origin. Okay, origin until this line. Origin until this line. Sampai ke garisan. Origin sampai ke garisan. So, garisan yang hitam atas ni diwakili oleh equation R equals to apa ni?
3.
Mana 3? Ni, color purple ni. 3 cos theta,
3 cos
yes.
theta.
Yes, R equals to 3 cos theta. So, R, limit of R start from 0, pole ni pole. Start from 0 until R equals to 3 cos theta. Understand?
Yes.
Okay, good. So, next, jom kita proceed. 0 until pi over 2, so we have r squared over 2, substitute. 3 cos theta, 0 d theta. So we have 9 over 2, right? So 9 over 2, 0 until pi over 2, cos squared theta, d theta. 92 saya keluarkan. Ni you all expert lah ni. Ni macam mana nak integrate ni?
1 over 2.
1 over 2.
1 minus.
Minus ke plus?
Plus.
Plus. Cos 2 theta. Alright. So we will have equals to 9. Okay, sekejap. Okay, 9 over 4 lah kan? Buat keluar. 1/2, 9/2 1/2. So 9 over 4 lah. So we have 0 until pi over 2, 1 plus cos 2 theta d theta. Okay, so we have 9 over 4, substitute theta. Integrate cos apa-apa?
Positive sign 2 theta
Yes,
over 2.
positive sign 2 theta over 2, substitute 0 until pi over 2. So we will have 9 over 4, substitute pi over 2 plus sin pi over 2. Dua darab pi baru jadi sin pi lah. Ni kosong ni. Okay, and then minus kosong-kosong lah. Gantikan 0 kan. Tak ada apalah. So, we will have 9 pi over 8. Betul jawapan ni. 9 pi over 8. Question number 13. Yes, okay. So, 9 pi over 8. Okay, one last question. Kita buat volume lah pula. Satu lagi soalan, volume. Let's say we have this copy. Kita nak semayang asal kan? Tak apa guys, nanti saya share notes ni. Alright. Okay. Z equals to 8 minus 2x squared. This one. So let us sketch the 3D graph. Sebab dia nak volume kan. Volume maksudnya 3D lah. Dia ada solid. Okay, so X, Y and Z. Z equals to 8 minus 2x squared. Ni. This one. So we will have a paraboloid, isn't it? Downward paraboloid. Paraboloid, mangkuk tom yang tumpah ni. So you will have something looks like this. Then this one. And this one. Okay, so this is 3D lah. 3D. And then here should be 8. Okay, on the plane Z equals to 0, of course we will have region R. Region R kat bawah ni. This is region R. The whole thing is region G. Ni kita belajar dalam subtopic nanti 4.6 ada triple integrals in cylindrical coordinates. So now let us sketch region R. Region R ni apa saya kata tadi? XY plane kan?
Ya.
So XY plane ni adalah apabila when Z equals to 0. Okay. So when Z equals to 0. So we have Z equals to 8 minus 2x squared plus y squared. So when Z equals to 0, we will have 8 minus 2x squared plus y squared equals to 0. So we will have 2x squared plus y squared equals to 8. So
Z squared plus y squared equals to 4.
So 4, yes. So in polar, this is actually R equals to
2.
Okay, so your region R would be a circle. A circle. Okay, region R awak adalah a circle with radius 2. X and Y. So dia ada macam ni lah. 2, 2. So this is your region R. Okay. So dah settle guys. Volume. Formula of volume tadi saya ajar apa? Equals to double integrals towards region R. F. In this case FR theta lah. And then dA. Of course FR theta is actually your what?
Second Z angle.
So your Z. Okay, since Z equals to 8 minus 2x squared plus y squared, therefore in polar, Z equals to 8 minus 2 what?
R squared.
Squared, yes, very good. So we will have a double integration volume equals to, okay, Z is 8 minus 2r squared.
R
Okay.
dr dθ.
Yes, now dA ni adalah R dr d theta lah. Okay, multiply by R dr d theta. Okay, now according to this region R ni, apa limit kita? R from? Tengok tu lupa lah tu saya kata apa daripada equals to 0 until R equals to 2.
2.
Okay, and then the theta of course very simple soalan ni.
Pi.
Yeah,
0 until 2 pi.
Yes, so we can have integration from 0 until 2 pi, 0 until 2, we have to multiply to 8r minus 2r cubed dr d theta. So 0 until 2 pi, integrate 8r, you will get 4r squared minus r to the power of 4. 2 over 4 means over 2 lah. So we have 0 until 2 d theta. So 0 until 2 pi, 4 kali 4, 16, 16 minus 16 over 2, 8. Minus 0, 0 minus 0, d theta. So we will have 8, 0 until 2 pi, d theta. So 8 multiplied by theta, substitute 2 pi and zeros, therefore the answer is 16 pi. Okay, understand guys?
Faham.
Okay, so I think that's all for today. Thank you very much for your attention. For the Muslim, we finished with tasbih, kafara, and